Hello everyone, this is Anmol Gira, and today we're going to see a very interesting question called sliding window maximum. This is a standard question. Like हमको करना क्या है? Okay, so I'll try to speak in English. Okay, so what we have to do is that we have an array of size, let's suppose n, and there is a sliding window of size k, which is moving from the very left to the very right. Okay, and you can only see the k numbers in the window. So each time the window sliding, so basically every time it slides by one step. So if we just see the input, let's suppose so 1 3 minus 1, the maximum is 3. We have to basically find the maximum of that particular window and return the return the whole vector. And okay, so as you can see, it's minus 10 to the power 4 to 10 to the power 4. To technically is 10 to the power 8. So we have to do this in all around in one iteration basically. Basically on. That's the expected time complexity. So okay, let's just see the example first. Let me just zoom out a bit. Okay, so let's suppose so for this for the value of case 3, the first three sizes like 1 3 minus 1, the maximum would be 3. Similarly in this, the maximum of these three element would be 3, so 3. Now the maximum would be 5, so 5. And basically in this the maximum would be 5, similarly 5 and 6 and 7. That's the answer. So we have to run this vector. The size would be n minus k plus 1, 3 and 8. So 8 minus 3 plus 1, 6. 6 should be the size. Like if we do this ideally, we'll find out the size would be n minus k plus 1. Okay, so let's just discuss the brute force approach first. You should always try the brute force first because sometimes the test cases are weak and you can be lucky. So what is a brute force? That one by one we start from, let's suppose, an ith index. We'll traverse the you can say window of size k from I to I plus k. This would happen n minus k plus 1 times. And in each window we'll find the maximum, simply put, and we'll push back that into the vector we have made. So that would be the brute force approach. This is pretty trivial. Let's just see the code for this first. Okay, so it will get TLE. Let's see, in a test you can just pass it. If you're lucky, you still have 50 test cases pass. Right? Okay, so this is the code. Total number of windows would be num dot size, n minus k plus 1, and similarly I just maintained a max. And for from every index I to I plus k, I'm just calculating the maximum and putting that into the array, into the vector. Yeah, the vector is again n nums dot size minus k plus 1 size. That is it. Okay, so this is the brute force approach, which is very, very trivial. Like if you're doing hard questions, so you're expected to at least come up with a brute force solution. Okay, so now what's the exact solution? Okay, so I just want to show something. So let's suppose in this, if you observe carefully in windowing now, we are adding one element from this side and deleting one element from this side. Similarly, when we'll go from here to here, basically we are adding one element and deleting one element. So if we carefully observe, so there's a data structure called DQ. So okay, what DQ does is, in DQ we can push back an element in the back and push back an element in the front, and similarly we can pop an element from the front and pop an element from the back. So this is a DQ data structure, which we'll sort of gonna use here. Okay, so let me just first. So yeah, so what DQ want us do is first we'll we'll create a max. You can say it's sort of a monotonic sequence, which is increasing like this. So this is an easy example. I'm just taking the example so you can understand carefully. First, so let's suppose for 1, 2, and 3, this is 1. Beg your pardon. Now this is 1. Okay, so let's suppose we push a 1. There is no element in the DQ, so we'll push an element in the DQ. Let's suppose 1. Then when we'll push 2, so we'll see if dq dot back, the element that we have pushed, if that is basically less than ai, the elements we have in the dq, if it's less than ai, so we'll simply pop it out, and we'll pop it out till when till this condition holds, till dq dot back is less than ai. For this basically iteration, this is, we'll push 1, then we have 2, since this is in the dq, so dq dot back 1 is less than 2, so we'll pop out 1. Now we'll pop out 3. Again the same thing will happen, that since dq dot back, in dq now we have 2 and 3 is basically nums I, it's not in dq yet, so dq dot back is less than num I. It basically means that this is a better element to meant to have a max, so basically we'll pop out this again, and 3 would be our element in dq. Now when our I reach k minus 1, when basically we are on this index, from k minus 1 basically we have to, for index k minus 1 we should have our first answer ready, right? So when I is equal to k minus 1, the element which we'll have in the front would be the element which is maximum by this approach. And like we have one more clue. The clue is that basically the maximum, let's suppose this was the case, 1 2 3 4 5, so the maximum element would be in front. And when basically when basically ai minus k plus 1 equal to dq dot front, so like there is a limit, that we can extend an element, like 3 can only be maximum till this range, and finally till this range. In this range it cannot, we cannot take 3, we have to delete 3. So when we delete 3, when basically a I k plus 1, this is the extreme case, if this is equal to in this I equal to k minus 1, so this basically means 0, I equal to basically k minus 1 in this case. So if in dq dot front we have 3, so for this particular value of I, in this I would be this. So for this is on 4th index, so 4 minus 3 plus 1, which would be a of 2. So basically we can take this max till this. After this I have to delete it. So when this a of I minus k plus 1 is equal to dq dot front, we have to pop it out. Let's just see the code, you'll understand. The logic is pretty simple. You have to maintain a dq, and it's some sort of a monotonic sequence. You just see the code, you'll understand. That's my guarantee. Okay, so just zoom out a bit. Okay, so basically this is the code. Just maintain a vector, maintain a dq, and like this is for nums dot size, while dq is not empty and dq dot back is less than nums I, dq dot pop back. The same logic, if our current element is basically greater than the dq dot back, till our current element is greater than dq dot back, we just have to pop out those elements, dq dot back. So in this point we'll have the maximum element with ourselves. Then when I is equal to k minus 1, we have to basically push back front, because in front we will have the maximum element. And if num I minus k plus 1 equal to dq dot front, it means that we can only take that element up to that particular range. After that it's not possible, so we have to basically pop it out, and simply we are returning the vector. So this is the code. I'll post a link to both the codes. If you want to see, you can check that out, or I think this you can just take a screenshot. Like this is pretty, I think, standard stuff. Okay. So thank you very much. The question was pretty good. If you were not able to like do it in the very first time, don't be sad. I could not also solve it for the very first time when I was also unable to solve it. So yeah. So that's it. If you have doubt or if you do not understand anything because I just speak very very fast, I know. Just let me know in the comments and I'll be like slow next time from next time onwards. Okay. Thank you very much.